Hi children, welcome back. In the previous video, we had discussed about midpoint. Today, we are going to discuss about slope of a line. Children, look at this picture. We can draw a straight line joining any 2 points and we can extend it as much as we like to either side. If the x coordinates of the points are equal, then the line would be parallel to the y-axis, and if the y coordinates are equal, it would be parallel to the x-axis. Next, if both the x coordinates and the y coordinates are different, the line would be slanted, not parallel to either axis. Such lines are called slanted lines. Once again, slanted lines. Children, look at this picture. As we move along this line, the x coordinate and y coordinates change at every point. There is a rule to this change. See this picture. It shows the line joining the points 2, 5, 6, 7 and two other points x1, y1 and x2, y2 on it. We have also drawn two right triangles with these two pieces of the same line as hypotenuse and the perpendicular sides parallel to the axis. We can mark the lengths of these perpendicular sides like this. The perpendicular sides of the lower triangle are 4 and 2. That is, the vertical side is half the horizontal side. It must be so for the upper triangle also, because these two triangles are similar triangles. In this case, x1, y1 and x2, y2 can be any 2 points on the line. Then y2 minus y1 equal to half into x2 minus x1. For any 2 points on the line joining 2, 5 and 6, 7, the y difference is half the x difference. Okay, let's go for one more example. As we move along the line joining 1, 4 and 5, 12, the x coordinate increased by 4 and y coordinate by 8. In other words, the y change is twice the x change, and the same is true for any 2 positions on the line. Thus, in moving along this line joining 1, 4 and 5, 12, the change in y at every stage is twice the change in x. Children, what do we see in general in all these? Yes, in any line not parallel to either axis, the change in y coordinate is product of the change in x coordinate with a fixed number. Or we can say that in any line not parallel to either axis, the change in y is proportional to the change in x. Okay, look at this picture. Geometrically, the x difference is the horizontal shift and y difference is the vertical shift. Okay, the x difference is the horizontal shift and the y difference is the vertical shift. Okay children, then we can say that on dividing the y difference by the x difference, we get a rate of change of the vertical shift with respect to the horizontal shift. In other words, we can say that the constant of proportionality of the change in coordinates of a line is a measure of the slant of the line. It is called a slope of the line, and the formula is y2 minus y1 by x2 minus x1. Once more, slope is equal to y2 minus y1 by x2 minus x1. Is it clear for you children? Okay. Let's do some exercise questions on page number 227. Okay. Are you ready? Okay. Question number 1. Prove that the points 1, 3, 2, 5 and 3, 7 are on the same line. We have to prove that all these 3 points lie on the same line. So, let x1, y1 equal to 1, 3, x2, y2 is equal to 2, 5 and x3, y3 equal to 3, 7. To prove this, we have to find the slope of these points. Okay, first of all, y2 minus y1 by x2 minus x1, which is equal to 5 minus 3 by 2 minus 1, which is equal to 2 by 1, and it is equal to 2. Next we have to find the slope between x3 y3 and x2 y2. Slope is equal to y3 minus y2 divided by x3 minus x2, and it is equal to 7 minus 5 divided by 3 minus 2, which is equal to 2 by 1, and it is equal to 2. Okay, next we have to find the slope between x3 y3 and x1 y1. Okay, slope is equal to y3 minus y1 divided by x3 minus x1, which is equal to 7 minus 3 divided by 3 minus 1. 7 minus 3 divided by 3 minus 1. So which is equal to 4 by 2, and it is equal to 2. Okay. Here the slopes are equal, hence the points 1, 3, 2, 5 and 3, 7 are lie on the same line.